last problem, we're going to calculate the integral from 2 to 4 of f of x dx, assuming that, and we're given 3 different integrals and what they equal. Okay, so what we have to do, what we really have to be careful with is these limits of integration. They can be kind of tricky. So what we really want is for us to start integrating at 2 and end integration at 4. Okay, so start the integration at 2, that means that we want a 2 on the bottom to start with. So that means the only integral we see that we're given is this one right here. So we want that 2 on the bottom, so what we'll actually have to do in order to find the integral from 2 to 0 of f of x dx is this is equal to the negative of what we're given, so 0 to 2, right? So that's what we really want, so this is the one that we want here. Okay, so that's what we're going to plug in, and we're going to keep in mind that this is equal to the negative of what we were given. Okay, so 2 to 0, that integral is equal to negative of whatever we were given, which was a 4, right? So negative 4, that's going to be our answer for this first integral here. And then what we're going to have to do, because we want to end up at 4, not at 0. Right now we're at 0, so we want to use these other integrals in order to get to that 4. Okay, so what we're going to have to do is use the additivity of adjacent intervals, right? So if we're starting here, so we start with 2, and now we're traveling to 0. Okay, so we have this, and we know that this is equal to negative 4. And then what we can do is add it to something that starts at 0. So let's look at one. This one here on the left, that one starts at 0, and it goes up to 1, which still isn't 4. So that's kind of a bummer. But we can also continue on. So now we'll start with something with 1. So that's perfect here. We have this right integral there, and it does happen to end at 4. So great. So this is a perfect equation here, or expression, right? So what we're going to do, so we start at 2, we go through 0, okay? We go through 1, we pass by that, and we end up at 4. So that's going to be, that's going to work out nicely, okay? So this one here, we found out that that is equal to a negative 4, right? Because remember, we had to flip those, we had to reverse the limits of integration there. And then we have plus, and this integral here was what, just as it was given, so that would just be a 1, plus a 1. And then this last one is going to be just as it was given as well, so that's just a 7 there. 7. So we have negative 4 plus 1 plus 7, so that's negative 3 plus 7, so that'll end up being a positive 4. Okay? Alright, so that does it. That wraps it up for our practice problems video on the definite integral. I hope that helps, and happy studying.